take a look at this problem. P is equal to 200 minus 5x. And we're specifically wondering when x is equal to 20. The instructions are to find the price elasticity of demand for the demand function at the indicated x value. Is the demand elastic, inelastic, or of unit elasticity at the indicated x value? Now, even though technically the instructions are such that we wouldn't have to find the interval, I'm going to go ahead and find the intervals of elasticity so we can see that. Now, eta, and I don't draw the symbol very good, so let me show you what it should look like. It's like this weird looking in. That's going to equal to p over x all over p prime. Well, I got p, I got x, but I don't have p prime. So the derivative of 200 minus 5x is negative 5. So eta, we're going to have p, which is 200 minus 5x over x all over p prime, which is negative 5. Now, whenever you have a single fraction over another denominator, you can put that denominator down with this one. So this becomes 200 minus 5x over negative 5x. Now, we're specifically analyzing this right here, when the absolute value of eta is equal to 1. So I'm going to solve the absolute value of 200 minus 5x over negative 5x is equal to 1. Now, an absolute value equation, whenever you have an absolute value equal to something else, you drop the absolute value. So 200 minus 5x over negative 5x, and you set it equal to positive the other side, and you set it equal to negative the other side. Now, we want to solve each one of these. On this first equation, I'll multiply both sides by negative 5x, and I get 200 minus 5x is equal to negative 5x. Take this negative 5x over, and we get 200 equals negative 5x plus 5x, which is 200 equal to 0. Our x disappeared, so we dropped that piece completely. Now over here, I'll multiply both sides by negative 5x, and we get 200 minus 5x is equal to negative 1 times negative 5x gives us a positive 5x. I'm going to take this over, so we get 200 is equal to 5x plus 5x, or 200 is equal to 10x. Divide both sides by 10, and we get x is equal to 20. Now that's our critical value. So we got x is equal to 20. Now, even though it doesn't make any sense, let me put negative infinity here, and I'll put positive infinity over here. We want to choose test cases. I'll choose something between, and I'll choose 0 and 20, because that makes more sense, but I'll put 1 in. Then I want to choose something greater than 20, like 30. And we want to plug those into the absolute value of eta. So we're specifically taking a look at the absolute value of eta, this right here. So absolute value of 200 minus 5 times 1 over negative 5 times 1. 5 times 1 is 5. 200 minus 5 is 195 over negative 5. Now, specifically what we're looking for is whether it's greater than 1 or less than 1. I have no clue what this is equal to, but I know it's greater than 1, which tells us if it's greater than 1, it's elastic. So that interval is elastic. Now, if I plug in 30, got 200 minus 5 times 30 over negative 5 times 30. 5 times 30 is 150. 200 minus 150 is 50 over negative 5 times 30 is negative 150. And what is that? Negative 1/3, which is positive 1/3, which is less than 1, which means it's inelastic. Again, we're just using that as a test case to determine elasticity. So let me write out what I just said. It's elastic when x is less than 20. And it's inelastic when x is greater than 20. Well, let's look at the specific case they give us in this problem. They're telling us to analyze it when x is equal to 20. Well, to begin with, 20. Well, when it's 20, that's an interesting one. Eta, which is equal to 200 minus 5x over negative 5x. If I were to put that in there now, we get 200 minus 5 times 20 over negative 5 times 20. 200 minus 100 gives us 100 over negative 5 times 20 is negative 100, which gives us negative 1. Then the absolute value of eta is going to give us the absolute value of negative 1, which is a positive 1. So it's neither elastic or inelastic. It's this critical value right here, which means it's of unit elasticity. I didn't realize I'd put one of those in there.